Today I'm going to show an example of how we can use the attiny85 to solve a quite common problem that you need to have a more accurate timing on your Arduino project. Like in an example where you have, for example, an anemometer, a wind sensor that you have external interrupts when the wind is blowing. And then you need to, in order to establish how many rotations you have for that wind sensor per second, for example, or over a duration of seconds, then it gets quite complicated if you start mixing those external interrupts with internal timers, especially if you're in sleep mode. But then you can utilize one of these small chips to use as a clock, or to have that accurate timing. And I will show you how. I mean, you can also use an real-time clock module if you want to, but it's really cheap. A few crowns or $1 or so, you can get this one on these attiny85s. I usually build it just using a simple breadboard and a header to create this kind of module like this. So it's the same, just some color in it to look a bit nicer, and then it's the same attiny that you can see the pinout for here. So this is the minimum. These 6 pins that you see here is what you minimum need to be able to program it. And then when it's running, it's actually just using the VCC, the ground, and then the digital 2 in this example. So you only need 3 pins when operational. Then I'm programming it using an USB tiny ISP. You can program it using your Arduino Uno on all sorts of setups, but here I've just created, so this is just a breadboard I'm using to remap the pins to suit this, since I'm reusing this programming adapter for various projects. So this one is already programmed, but you just slot it in and program it, and then just remove it. So program it with your Arduino or Platform I or whatever, using it, upload using a programmer. If we, just to illustrate how low we can get here from how it works and how low we can get from a power consumption point of view, I have a LED here to show how we're just flipping the digital 2 here. So we put some power to it. You can use 5 volts or 3.3, whatever. As you can see, the only operation for this little device here is to be in deep sleep for 1 second, and then flip that digital 2 to high and then to low the next second. So it doesn't do anything more. And if we look at the current consumption using my current ranger, we can then see what the power consumption is. As you can imagine, this LED will drive power. So every time it switches on, it will consume power, and that's nothing that we want to use in our real application here. So this is typically then just a slave processor that is creating these interrupts, and then you have maybe an Arduino Mini Pro also in some kind of sleep mode, but also listening on other interrupts. And as you can see here on the current ranger, it's 3.6 milliamps when the LED is lit. So if we switch this to microamp mode, it's down to sort of 6, just above 6 microamps when in sleep mode. So that's where it's going to be most of the time. If you have it connected to an Arduino, you won't have any power consumption from that, not that high. So again, this is a very nice and simple solution to, of course you need the extra circuit, but it will save you quite a lot of hassle when trying to get the timings right if you're going to integrate this into your other normal Arduino product. Of course you can use this shipped for lots of other stuff, but even as simple as that, to just have flipping one bit and generating these interrupts once per second or once per 8 seconds or whatever you want to program it for. That's a quite neat way to do things. Thanks.